The joy of learning and intrinsic motivation. There's something they never told you in school. The boredom you felt sitting in those classrooms, staring at textbooks, watching the clock tick toward the bell. That wasn't you failing at learning. That was learning failing you. Because here's the thing. You were born curious. Every single one of you. Before school ever got its hands on you. Before grades and deadlines and standardized tests. You were a learning machine. You touched hot things to understand heat. You dropped objects off high chairs to understand gravity. You asked why so many times that the adults in your life ran out of answers. That wasn't a phase. That was your natural state. That was you, operating exactly as nature intended. So what happened? Somewhere along the way, learning got hijacked. It got wrapped up in obligation and performance and fear. It became something you did for a grade, for a degree, for a job, for someone else's approval. And slowly, almost invisibly, the joy drained out of it. The curiosity that once kept you up at night turned into anxiety that kept you up before exams. The wonder got replaced by dread. But here's what nobody tells you. That original curiosity never actually left. It's still in there. And one man's entire life stands as proof that it's possible to keep it burning, not just into adulthood, but all the way to the very end. That man was Richard Feynman. Richard Phillips Feynman was, by any objective measure, one of the greatest physicists who ever lived. He won the Nobel Prize. He helped build the atomic bomb. He revolutionized how we understand quantum electrodynamics, the theory describing how light and matter interact. He sat on the presidential commission that investigated the Space Shuttle Challenger disaster and solved the problem with a rubber O-ring and a glass of ice water in front of live television cameras. But if you asked the people who knew him, who worked alongside him, who listened to him lecture, none of that is what they remember most. What they remember is the joy. The almost embarrassing, completely unguarded, absolutely infectious joy that Feynman brought to every single thing he tried to understand. He played bongo drums in Brazilian samba bands. He learned to crack safes and spent months doing it inside Los Alamos just because he could. He taught himself to read Mayan hieroglyphics. He painted portraits. He picked up the art of storytelling and used it to explain physics in ways that left audiences breathless. And through all of it, through the Nobel Prize and the bongo drums and the hieroglyphics, there was a single thread connecting everything. Genuine, uncomplicated, almost childlike pleasure in understanding how things work. This wasn't performance. This wasn't a brand. This was just Feynman being Feynman. And it raises a question that deserves serious attention. What did he know about learning? About the relationship between curiosity and understanding that most of us have forgotten? Let's start at the beginning. Not Feynman's beginning, but yours. Think back to the first time you ever experienced genuine intellectual wonder. Maybe you were 5 years old and someone showed you that a magnet could move things without touching them. Or you were 8 and you looked up at the night sky and realized those weren't just decorations. Those were actual places, incomprehensibly far away. Or you were 12 and someone explained that the atoms in your body were forged inside stars that exploded billions of years before Earth even existed. Remember that feeling? That particular sensation, somewhere between awe and vertigo, where your understanding of reality just shifted? That feeling has a name. Feynman called it, in various ways across his life, the pleasure of finding things out. It's not just a poetic phrase. It describes a very specific cognitive experience, the moment when confusion resolves into clarity, when a pattern suddenly emerges from apparent chaos, when the world reveals a small piece of its hidden structure to you. And here's something fascinating about that experience. It's intrinsically rewarding, meaning your brain treats it like a prize. Neurologically speaking, genuine understanding triggers the same reward pathways as food, as social connection, as physical pleasure. Your brain is literally built to find learning enjoyable. So why doesn't it always feel that way? Because there's a crucial difference between learning driven by curiosity and learning driven by external pressure. One of them works with your brain's natural reward system. The other one overrides it. When you learn because you genuinely want to understand something, because the question itself is pulling you forward, your brain is operating in its natural exploratory mode. Attention is effortless. Time distorts. We follow threads wherever they lead, not because you have to, but because you can't help it. But when you learn because you have to pass a test, because someone is grading you, because failure carries consequences, something different happens. The goal shifts from understanding to performance. And performance anxiety actively suppresses the very cognitive processes that make learning feel good and work well. You're no longer exploring, you're executing. And execution, under pressure, is exhausting in a way that exploration never is. Feynman understood this intuitively. He talked about it openly and often. And at one of the most important moments of his career, he made a decision that illustrates exactly what that understanding looks like in practice. Here's a thought experiment. Imagine you're in your late 20s. You've just done some of the most intense intellectual work of your life, contributing to the Manhattan Project, working alongside the greatest physicists of the 20th century. You're brilliant, everyone knows it, and you're completely burned out. That was Feynman in 1945. The war had ended. He was at Cornell, supposed to be doing great physics, and he was sitting there unable to produce anything. The weight of expectation, his own and everyone else's, was suffocating. He felt like a fraud. He felt like he'd peaked. He was doing physics because he was supposed to, because people expected it of him, because his identity as a scientist demanded it. And then something small happened. He was sitting in the Cornell cafeteria and someone threw a plate in the air, just playing around, one of those idle cafeteria moments. And Feynman noticed something. The plate wobbled as it spun, and the wobble had a particular relationship to the spin rate. And for absolutely no reason, no paper, no deadline, no application, he started thinking about why. He went back to his office and started working out the mathematics of the wobbling plate. Just because it was interesting. Just because he wanted to know. Not because it mattered. Not because it would advance his career. Not because anyone asked him to. And the joy came back, immediately, completely, unmistakably. He described it later as the excitement of learning something. The wobbling plate led to other problems, which led to other questions, which eventually, through a winding and unpredictable path, led to the work that won him the Nobel Prize. But here's what matters most about this story. He didn't know it was going to lead to a Nobel Prize. He wasn't calculating. He wasn't strategizing. He was playing. He was doing physics the way a child plays with blocks. Not to build anything in particular, but because the act of building is intrinsically satisfying. Stop. Think about that for a moment. The work that earned Richard Feynman the Nobel Prize in Physics grew directly out of a moment of completely purposeless play. Out of curiosity with no agenda, out of the simple pleasure of noticing something interesting and following that thread wherever it led. Now, you might be thinking, that's fine for a genius. That's fine for someone whose natural curiosity already runs in the direction of physics. But what about the rest of us? What about people who don't naturally find wobbling plates interesting? What about people who've been sitting in classrooms for years having the love of learning systematically drained out of them? Fair question. And the answer is more hopeful than you might expect, because Feynman's curiosity wasn't selective. It wasn't physics curiosity or science curiosity, it was generalized wonder. He was fascinated by everything, not because everything is equally fascinating, but because he had developed a particular relationship with not knowing that most of us never cultivate. Here's the thought experiment that illustrates this. Imagine two people looking at the same flower. Person one sees the flower and thinks, that's beautiful. Full stop. The beauty is the end of the experience. Person two sees the flower and thinks, that's beautiful. And I wonder how those colors got there. What's the pigment? What is it actually made of at the molecular level? How do bees see it? Do they see it the same way I do? Why did evolution produce this particular shape and this particular color? Is there a relationship between the spiral pattern of the petals and the Fibonacci sequence? Person two isn't a scientist. They're not a botanist. They're just someone who has learned to treat a question mark as an invitation rather than annoyance. Feynman talked about this directly. He described walking with his father as a child, and his father pointing out a bird and saying, that's a brown-throated thrush. And then his father would say, but knowing its name tells you nothing about it. Do you know how it migrates? Do you know what it eats? Do you know how it sees the world? His father taught him, from the very beginning, that naming something is not the same as understanding it. And that understanding, actual understanding, kind that comes from wondering and questioning and exploring, is always more interesting than the label. This is one of Feynman's most important contributions, not to physics, but to how we think about thinking. The joy of learning doesn't require genius. It requires permission. Permission to be curious, without justification. Permission to not know and to find that exciting rather than threatening. But here's where it gets interesting. Because this isn't just philosophy, there's something real happening in the brain when curiosity takes over, something that fundamentally changes the quality and depth of learning. Think about the last time you were genuinely curious about something, not assigned to learn it, not required to understand it, just authentically, personally curious. Maybe it was a documentary that grabbed you unexpectedly. Maybe it was a conversation that opened up a question you'd never considered. Maybe it was a book you picked up without any particular purpose. Now think about how you engage with that material. Did you have to force yourself to pay attention? Did you have to reread sentences 3 times because your mind was wandering? Did you feel that familiar Sunday evening dread about absorbing information that felt alien to your actual life? Probably not. When genuine curiosity is driving the process, attention flows toward the subject rather than having to be pushed. Details stick without effort. You make connections to other things, you know, without trying to. The learning feels less like filling a container and more like watching a map unfold. This is not a metaphor. This is what neuroscience is starting to confirm about intrinsic motivation and learning. When you're curious, your brain releases dopamine, and dopamine doesn't just make you feel good, it actually improves memory formation. It makes the neural pathways associated with what you're learning stronger and more durable. Curiosity, neurologically speaking, is a learning accelerant. And anxiety, external pressure, the kind generated by grades and deadlines and the fear of looking stupid, it does the opposite. Stress hormones actively interfere with memory formation and creative thinking. They narrow attention rather than broadening it. They push your brain toward mechanical execution rather than genuine understanding. Ironically, the very pressure schools apply to make students learn better is, at the neurological level, making it harder to learn at all. Feynman understood this without having the neuroscience to back it up. He understood it because he could feel the difference between the flat, effortful slog of learning he didn't care about and the electric, effortless absorption that happened when he was genuinely interested. Let's do another thought experiment. This one is important. Imagine you've decided to learn something entirely new. Let's say you want to understand how black holes form. You have 2 paths available. Path 1. You sign up for a course. There are textbooks, assignments, quizzes, a final exam. Passing the exam requires you to memorize specific facts and demonstrate specific skills. There's a deadline, there's a grade, there's an instructor whose approval you need. Path 2. You watch a documentary about black holes late one night because you couldn't sleep and the thumbnail caught your eye. It raises a question you'd never considered, and you Google it, and that answer raises another question. And 2 hours later, you're reading about the event horizon, and you genuinely cannot believe this is real. That the universe actually contains objects from which not even light can escape. That time itself slows down near their surface, and you stay up until 2 in the morning not because anyone told you to, but because you can't stop. Which version of you, at the end of that experience, has actually learned more? Which version could talk about black holes at a dinner party 3 months later? Which version found the whole experience rewarding rather than exhausting? The answer is obvious, and it suggests something radical about how we might think about our own education, not the formal education we received, but the ongoing self-education that, as adults, we actually have control over. You don't have to wait for a class to tell you what to learn. You don't have to justify your curiosity with practical applications. You don't need a credential at the end of it. You just need permission, which only you can give yourself, to follow the questions that genuinely interest you. This is what Feynman did his whole life, not just in physics, but in everything. He gave himself permission to be interested without needing a reason to be interested. There's a story Feynman told about a time an artist friend challenged him. The friend argued that science destroys the beauty of nature, that reducing a flower to its molecular components somehow takes something away from the experience of the flower's beauty. Feynman found this genuinely baffling, because for him, understanding the molecular structure of a flower didn't diminish its beauty, it multiplied it. He could see the flower, And he could also see that the colors existed because of specific molecules that absorbed certain wavelengths of light and reflected others. He could think about the fact that those molecules had evolved over millions of years in an ongoing visual negotiation with the insects that pollinated the plant. He could consider that the variability to perceive beauty, the aesthetic experience itself, was something that happened in his brain, a physical process involving electrochemical signals in specific neural circuits. None of that made the flower less beautiful. It made it more interesting, more layered, more connected to everything else. This is the gift that genuine curiosity gives you. It doesn't flatten the world, it deepens it. Every answer opens 3 new questions. Every explanation reveals another layer of mystery underneath. And the world, seen through this lens, never becomes boring, because the supply of interesting questions is literally inexhaustible. Feynman talked about this as one of the great underappreciated pleasures available to human beings. The universe, he felt, doesn't get less wonderful as you understand it more. It gets more wonderful. The more physics you know, the more astonishing the universe becomes, not less. Now, you might be thinking, I understand the philosophy, but how do I actually get back to this? How do I reconnect with genuine curiosity after years of having it conditioned out of me? The answer's probably simpler than you'd expect, and it starts with letting go of a particular story you've been telling yourself about learning. The story goes like this: learning is work. Understanding is a destination you arrive at through effort and sacrifice. The pleasure, if there is any, comes at the end, after you've mastered the material, passed the test, earned the credential. Feynman's entire life was a refutation of this story. For him, the pleasure wasn't at the end of the process. It was the process. The confusion was interesting. The false starts were interesting. The moment of not knowing was just as engaging as the moment of knowing, because not knowing was an invitation. The practical implication of this is significant. If you're trying to reconnect with the joy of learning, the first step isn't to find the right subject, or the right teacher, or the right format. The first step is to change your relationship with not knowing. Think of it this way. Right now, in this moment, there are thousands of things you don't understand. Things about physics, about history, about how your own body works, about why certain things are the way they are. Most people experience that list as a kind of ambient background ignorance, mildly embarrassing, not particularly interesting, something to be remedied only when practically necessary. Feynman experienced that same list as a menu of potential pleasures. Each gap in his knowledge was an opportunity. Each question mark was an invitation. What if you tried that? Not as a permanent personality transformation, but just as an experiment. The next time you notice you don't know something, not a gap that makes you feel inadequate, just a genuine absence of understanding about something real. What if you followed it? Not for a grade, not for a credential, not to impress anyone, just to see where it goes. There's a particular quality to the questions that tend to unlock genuine curiosity. Feynman identified it without necessarily naming it directly, but it shows up clearly in the kinds of problems he chose to engage with. The questions that engage us most deeply are usually the ones that connect to something we care about, not professionally or academically, but personally. The questions that arise out of genuine wonder rather than dutiful inquiry. A third thought experiment. Imagine you're watching a sunset. Now, if you're operating in ordinary mode, the mode most of us live in most of the time, you see a beautiful sky, maybe take a photo, and move on. The beauty registers, and that's the end of it. But what if, just for a moment, you let yourself actually ask what's happening? The colors are different from the midday sky. Why? Something about the atmosphere. But what, exactly? The light is traveling through more atmosphere when the sun is near the horizon. Why does that make it red? What is the atmosphere actually doing to the light as it passes through? And suddenly you're in the middle of a physics problem. Not an assigned problem, not a test question, but an actual mystery generated by an actual observation of the actual world around you. And the answer? That different wavelengths of light scatter differently in the atmosphere. That the blue light scatters away, leaving the red and orange to reach your eyes. That answer is genuinely interesting. It connects to rainbows and to why the sky is blue in the first place, and to the fact that on planets with different atmospheres, sunsets look completely different. One genuine question asked in genuine curiosity opens into an entire landscape of connected understanding. This is the structure of learning that Feynman inhabited his whole life. Not a linear march through predetermined curriculum, but a branching, self-directed, following the thread, wherever it leads, exploration of whatever happened to catch his attention. The curriculum was reality itself, and reality, it turns out, has excellent material. There's one more thing worth saying about Feynman's relationship with learning, something that doesn't get talked about as much as the joy and the curiosity, but that was just as central to who he was. He was genuinely, consistently, almost aggressively comfortable with not knowing, in a culture that treats uncertainty as a weakness, that rewards confident answers and penalizes visible confusion. Feynman took the opposite position. He thought not knowing was not just acceptable, but actually interesting. He thought the honest acknowledgement of ignorance was more intellectually valuable than the performance of false certainty. He said once that he was comfortable not knowing things and not being sure, and that he found it much more interesting to live with questions than to live with answers that might be wrong. There's something almost radical about that. In academic settings, in professional settings, in most social settings, not knowing carries a cost. It makes you look uninformed, unprepared, less capable. Feynman rejected that entirely. He thought that pretending to know things you don't know was one of the most corrosive intellectual habits a person could develop, because it closes off the very curiosity that leads to genuine understanding. If you already know something, you stop asking questions about it. And if you stop asking questions, you stop learning. The willingness to say, "I don't know, but I find it interesting that I don't know," that is not a confession of ignorance. That is the beginning of every real discovery. Here's what all of this adds up to. The joy of learning is not a childhood luxury that responsible adults have to outgrow. It is not a luxury at all. It is the natural state of a human mind engaging with a universe that is, at every scale and in every direction, genuinely and exhaustively interesting. What most of us have experienced as boredom with learning is not an indictment of our capacity for curiosity. It's a consequence of learning being embedded in systems that prioritize performance over understanding, credentials over wonder, anxiety over exploration. Those systems did something real to most of us. They're not imaginary. The damage isn't imaginary. But here's the thing about damage. It can be undone. Not all at once, not without effort, but undone. And the path back is actually not complicated. It doesn't require going back to school, or finding the right teacher, or mastering the right techniques. It requires permission. Just permission. Permission to be curious, without justification. Permission to follow questions without knowing where they'll lead. Permission to not understand something and find that interesting rather than threatening. Permission to learn because the learning itself is worth having, not as a means to something else, but as its own reward. Feynman gave himself that permission, and he gave it so completely, so consistently, so publicly, that watching him, even decades later, through recordings and books and the memories of people who knew him, makes it feel possible for everyone else too. Because that's the real gift Feynman left behind. Not just the physics, extraordinary as that is. Not just the Nobel Prize or the Feynman diagrams or the path integral formulation of quantum mechanics. The real gift is the demonstration, the existence proof, the living, laughing, bongo playing, safe cracking, Mayan hieroglyphic reading, proof that a human being can move through an entire life, driven by genuine curiosity, finding the world endlessly interesting, approaching even the most difficult problems with something that looks less like work and more like play. He looked at a wobbling plate in a cafeteria and followed the question, and it led to a Nobel Prize. But that's not the point. The point is that the following was its own reward. The understanding was its own reward. The pleasure of finding things out, not so that anything could be built or proved or published, but just because the thing was interesting and the finding was joyful. That was the point. You had that once. You were born with it. Before anyone told you what you were supposed to be interested in, before anyone graded your curiosity, before learning became work, you had exactly what Feynman spent his whole life cultivating. It didn't go anywhere. It's still there. The question is just whether you'll give yourself permission to use it again. And if you're here, if you spent this time exploring these ideas, following these threads, maybe you already have. The universe is full of wobbling plates. All you have to do is notice them.